Welcome, it's Jerry here. Look what I've got on the bench today. This is something that I've just made up. It's called RetroVGA, and it's a kit that allows you to use a $5 Raspberry Pi Pico to emulate a bunch of different old-fashioned computer systems and video game consoles, including the ZX Spectrum, Commodore 64, VIC-20, Atari 800, ZX81, you name it, this thing can emulate it. It's got a built-in keyboard with arrow keys. It's got a VGA port for plugging into a monitor. It's got USB ports. It's even got an old-fashioned joystick port. If you're interested in old retro computers and consoles, then I think you're going to be excited about this. So join me. This is going to be a fun one. What I love about this is that the case is actually made up of PCBs. So there's all of these PCBs that have been manufactured and provided to you, but not all of them are for soldering components to. The PCB boards actually make up a three-dimensional case when you put it all together, and I think that's just super clever. This is the original listing. So the RetroVGA project, emulating these computers using a Raspberry Pi Pico. Get some instructions here about installation, some known issues. So there's Bobricius is the seller. So I think this is the old version. So we've got the newer revision of the board, but I think everything else is pretty much the same. It works in the same way. You've got the little keyboard there that will allow you to use it like a normal computer. You've got a VGA output. There's the joystick port. So you should be able to use an old school joystick. I think I've got one from my VIC-20. And then you're ready to rock and roll. I think that the newer versions that he's selling now actually have a screen on it, so you can use it as a portable game. Yeah, anyway, so yeah, you can see how that's working. I'll leave a link to the video in the description if you'd like to watch more of that particular video. Open the packaging and see what we've got inside. Sorry about the glare, I'm not really sure how to get rid of that. So that looks to be, what's that, the bottom plate? And this will be the keyboard, and this will be where everything is soldered to. And then we've got two bits that fit on the side. I mean, that's just clever, right? Build the case out of the PCBs. Excellent. All right. So the reason I'm not 100% sure whether I've bought everything is because the instructions for this particular revision of the board, I couldn't find too much on it. So I'm assuming that everything is self-explanatory. So I think I had better break out the parts that I did order off AliExpress and see what we've got. Should be serial somewhere. The one that I was most concerned about was the SD card slot. Whether or not that would be the right footprint for this. Right, so here is the SD card slot, and here are the pins. Did I get the right one? Damn, I think I did. Wow, that's a miracle. So I've got that. So I've got an SD card slot. What else have we got? We're going to need a joystick port and our VGA port. So there should be DB9s And I think they're all in this package. I think there's 2 sets, hopefully. Yeah, so we've got DB9 and VGA. Nice. Okay, and what else have we got? We've got the USB. It's going to go in there. I'm just checking the pinouts just to make sure that the form factor is correct. That looks correct, although I'm not going to push it down. But there's 4 pins. I might have to straighten a couple of those pins up. Get that in. But that's right. So I don't have an audio jack, which is a bit of a pain. We already know the SD card is going to fit, and then I need the Pico, which just solders directly onto it like that. Might be a bit of a challenge to solder, but that's all right. We can sort that out. Now, I did see some documentation on the internet that mentioned that the emulator, not all Picos are up to the task of overclocking, which the emulator requires, and it suggests that you install the what's it called, the emulator software, multi-machine emulator package onto here first and see that it actually works. And I did that, and it flashed. Apparently the LEDs flash on this to tell you that it's successfully installed, and that seemed to be okay, because you don't want to go soldering this whole thing on here and then find out that it doesn't work and you got to unsolder it. So on this side there is the markings blue, green, red, and there is room for resistors, and they are actually for the VGA connection. I thought they might be LEDs, but no, they're for the different colors of the VGA. And you can use either surface mount resistors or 3 holes, because he's provided both pads. Yeah, okay, so everything that is optional seems to be surface mount. Everything else can be surface mount or through hole. Cool. All right. Well, I think the best thing for me to do would be to start soldering some things on, starting with, according to the documentation, starting with the SD card, which will be a challenge for me, as I'm going to do it using a soldering iron. I think with a bit of magnification and the very thin tip soldering iron, I can get that on there. So I put a bit of flux on here. I've got some unleaded solder. I normally use leaded solder, but I'm going to try this. Yep. I think they're soldered on. Okay. Okay, so let's put the resistors on first. So we'll start with the 2K. So my resistors are a little bit too big, these 1/4 watt resistors. So I've just made them fit. They'll stand up a little bit, but that should be fine. There's plenty of room in this portion of the board, I believe, to make this work. had to force them in a little bit, but they should be fine like that. I was just looking at the board before I solder on my Pico, and it says here USB connect with wires TP3 to D+, TP2 to D-. So I think what that means is that we need to connect a wire between there and there for these pads to there. So we might just connect a wire now before we solder this on. So I'm going to solder this on here, and then I'm going to trim off leads after that. But it'll be easier to solder some small wires onto those pads before we do that. Alright, well that was a pain. So I've put all the buttons in. They're just sitting in the proper holes. I haven't tried to solder them in yet, because what I'm thinking is placing this on top to hold it in place, and then I might put some tape over it, and then I can turn it over and solder them. Alright, so that actually looks pretty good as far as that goes. So what other buttons do we need? We've got the larger buttons over here. Yeah, so the reset button, the escape fire, and these ones are going to be a different sized button. I'll need to find those. Well, I found some larger buttons, but unfortunately, although they fit, the hole on through the board isn't big enough. So we can't use those. So we'll just have to use the same buttons for the rest of them, because there is a footprint here for both, for the smaller button and the larger button. Yeah. So we'll just go ahead and do that. Just press fitting all of the components that I've got left to solder on. So the VGA, the serial port, the USB, and this USB port is not going to fit the way that it is, because the pins, the legs, are pointing downwards, and they need to be pointing at a right angle in order for it to fit in. So I guess I'm just going to try and manually bend them. I think it'll be alright. Okay, so it's time to solder the VGA on. Okay, let me just check all that. Looks good. Time for the USB-A, is that it? It's going to be a lot easier. Only 4 pins. Nice. So DB9 next. And there we have it. So all the peripherals are soldered on. We're almost home and hosed. Okay, so we need to think about the sound now. I found this Pezio speaker, but it's 12 volts. That's the only thing I could get. There's a part here for a Pezio speaker, LPT1109DS. I think that's a 5 volt. This is a 12 volt. I don't have the components to add the speaker or to add the audio jack. That's a surface mount audio jack. I think for the time being, what I'll do is I will just put this on, just for the first test that we do. This isn't permanent. I don't see any point about having that. Well, I'll try and get one of these connectors. Or maybe I can just find, I can connect a wire directly onto the back of that. Yeah, for the audio out. That's okay. What we're looking for now is just to see whether or not this thing lets out the magic smoke or it actually works, because everything is soldered on here. Let's give that a shot next. Okay, well, I apologise for the dodginess in the setup, but this is all I could come up with in the short term. So I've got an old monitor out of the cupboard, and yeah, I'm going to plug this thing in and see what happens. I genuinely have not plugged it in, so there's every chance that we could get the magic smoke. So I guess I'll just give it a go and see what happens. Have we got any leads going? Nothing. Okay, so let's try this again, because I couldn't remember what I'd actually programmed the Pico with. So I went to the Pico VGA project and downloaded one of the demo ROMs or files, and I have loaded that on. Yeah, we'll see if that works, and if it does, then we can move on to trying to get the emulators working. But really, it's the display that we care about at this stage, and that's what the project is based on, is this Pico VGA. So let's try it. Yes, I knew it. It's working. Wow, that is crisp. I was not expecting it to be looking that good. Okay, so we at least know that the Pico is working and the VGA is working. Let's figure out how to get an emulator on there. Alright, it's time to get some software onto this board and try some emulation. There are two projects that are mentioned that you can use with this board, and one of them is this one here. It is the MCUME emulator project, and the other one here is the Pico ZX Spectrum. So that's obviously to emulate a ZX Spectrum, whereas this one here, the MCUME, I think it stands for Multi-Computer Emulator. So it supports multiple boards and it supports multiple emulations. So looking down here, you can see that they support the Pico, the ESP32, the Teensy. There's a lot of information on this website. So we'll just go down. It actually shows you how you can build your own hardware if you don't have a kit like we have. And here is a list of the different types of computers that it supports. So ZX81, it's supported on all of these boards. So in this one here, in this table here, wherever you see Pico, is what we're going to be able to use. So it supports C64 and the VIC-20. And also these are the video game consoles that it supports. Not everything is working on every emulation, of course. So it looks to here like supporting a USB keyboard is supported on the teensy versions of the hardware. So I don't think it's supported on this version, the Pico version. So we can't expect to use a USB keyboard. That's why it's got the on-built or the inbuilt key functionality in it. The installation requires you to format an SD card and extract the contents of a zip directory, and it will create all these subdirectories for the different emulators, and then you just put your ROMs into those different directories, and then you need to program the Pico with the correct version of the emulator that you want to use, which we'll get to in a second. So this SD card that they're talking about, it's here. So you can see here sd.zip. You need to download that and unzip the contents onto an SD card. So if we want to get the firmware for the Pico version, we can just click on here onto the Pico link, and here's all the source code, but someone's already pre-compiled the source code into binaries, and if we go into the bin directory, you can see here's all the different systems that you can use with it. We're going to go for the Pico RetroVGA because that's what our kit is. Probably some of these other things might actually work, but if we go into this directory, you'll see that it's full of pre-compiled binaries. They have the UF2 extension, and this is for copying directly onto your Pico. And so we've got Pico 20, which I'm guessing is the VIC-20. We've got Pico 64, Pico 800, I think is the Atari 800, etc., etc. And so you just want to choose the ones that you want to install and download them. So for instance, if we want Pico 64, we'll just go here and hit download raw file button over here on the right, and that should download. I've already downloaded it, so there's a second copy, so that should just download a Pico 64 UF2 file, and now we just need to load that onto our Pico board that's soldered to the RetroVGA board. Okay, so you're not going to be able to see what I'm about to do, but I'm about to plug in the Pico via a USB cable into this computer, and there's a little button on the Pico itself which is labeled boot SEL, so I'm guessing that's boot select. So if you hold down that button and then insert the USB cable into it, it boots up into the programming mode where the Pico actually appears as a drive on your computer. And so then it's just a matter of going and finding the binary file that you want to load, and just pasting it into that drive. Done. So now when I disconnect it and I reconnect it, it's going to be loaded with that firmware, and we're going to be able to use that. So hopefully that will have loaded a Commodore 64 firmware into the Pico, and we can start emulating Commodore 64. Just a quick note on using ROMs or binary files and things like that. So the different emulators require different types of files, and you'll see them listed here. So for instance, the VIC-20 here, it says you need to put .prg files in that directory, and so the Atari 800s is looking for a .rom file, because there can be different formats of files if you go looking on the internet, and you need to make sure that you use the one that the emulator supports. So to set up the SD card, all I've done is download the sd.zip file off the website, and extracted the contents and placed the contents into the root of my SD card. I've had to use a SD card adapter for my computer to get that on there, but now I've extracted those. It's just a matter of putting the ROMs in the correct directories. You can have as many in there as you want. What directory it looks for files in will depend on what the binary is that you've currently got loaded. So for instance, I've got pacman.rom in the 800 directory for the Atari. That's not going to do anything if the firmware for the C64 is loaded. It's going to go directly to this subdirectory and it's going to find moonpatrol.prg, which I've already said is the correct type of ROM extension for the Commodore 64 being emulated here. So that's it. So we just need to take the SD card out, eject it, and place that into the RetroVGA board and connect it to the monitor, and hopefully we will see an emulation of the Commodore 64, and we should see what was it, the Moon Patrol ROM in there. So let's do that. Power on. Alright, there's my ROM. So I'll click the fire button. And there's our Commodore 64 system. So we can then go load and run. Sweet. Well, it works, but I have no sound, so I'm not really sure what's going on with the Pezio. I might look into that in a second. But there you go. So, Commodore 64. I was going to plug a joystick in and realised that I've soldered on the wrong port. I've put a female on there and it needs to be a male. But the other thing I discovered was, even if I put a joystick in there, it's not going to work unless you shorten the length of the cable from the joystick to the port to be 30 centimeters or shorter. Apparently that's some form of limitation electrically with this board. So that's a bit of a pain. Yeah, hopefully you can hear that. So the sound is working. I just bridged the connection between the two ends of the Pezio speaker. It's not very loud, so I think this calls for a 5-volt Pezio speaker, and I've got a 12-volt, so it's going to be less. That's fine. It works. That's all that matters. I think we should ditch the Pezio speaker. That's not going to be loud enough, and let's get the audio out working, and that way we can plug it into an external speaker. I know this looks a bit ugly, but I couldn't get an audio jack for this board, so I simply cut a cable and wired it directly to the board. I'm going to glue that down with some hot glue. I had to populate a couple of resistors and a capacitor over here also in order to enable the audio out, but I think that's everything that we need. So I had a bit of a problem putting the mechanics of this together. In the kit it talks about having standoffs, and it talks about having screws and things like that. The holes are 2mm. It's a really difficult diameter to try and find any screws for of the right length. I tried gluing the thing together and that didn't work, but in the end I think I've come up with a good solution, and basically what I'm doing is I've used rubber bands to hold the whole thing together, and then I'm simply taking some wire and poking it through all the way through, and then I'm soldering on top and bottom, and that will keep the whole thing together. And then if I ever need to pull it apart, I just simply need to desolder the wires at the bottom, for instance, and then the whole thing will come apart. So that's what I'm going to do. Well, here's the finished product, and I think it looks great. All nice and tidy. We've got our audio jack permanently wired in there, so we can plug that into some sort of speaker. And yeah, as I said, I soldered it together, checked all the buttons. So let's give this a go. That seems to work great. So why don't we move on to emulating a ZX Spectrum 128K and see how well that works. So I've just got this quick shot joystick connected from my VIC-20. It's faulty, it sticks sometimes, but it does actually move these menu items. So I guess joysticks are working on this system as well. Okay, well I think we'll leave the video there. I've had a lot of fun creating this little gadget, and I've certainly learned a lot. Hope you enjoyed it. I'll leave a link in the description to this hardware and the different websites that I used during the video. If you like what I've been doing, please consider giving me a thumbs up and subscribing to my channel, and I'll catch you later. Ciao.